Today we're doing Module 2, Lesson 5, where we're going to continue our work on unit rates. And this lesson wants you to dive in and handle a lot of stuff on your own, and then we're going to come back and talk about it afterwards. So the very first thing you're going to do is you're going to pause the video, and you're going to do questions number 1 and 2 on your own. Each one has 3 parts to it, and when you're done working those 3 parts, just sit tight and we'll come back and talk about it in class. So how those questions work out for you? When I did them, I realized that I couldn't really answer the A's until I did the B part. So the B part wanted me to take and find the unit cost of each item. Which for the apples, it would be how much is 1 pound of apples cost, and for the crayons, it would be how much does each crayon cost. So I did my work here, and I guess I kind of need to put a little bit more information into this. So let me take, and we'll go back over here, and I need to include some dollar signs, and I need to set it up as per pound for these. And this one is going to be per crayon. So give just a little bit more information, because we have to say what our units are in our unit rates. Alright, now that we got that done, to find the unit price of the apples, I took each total cost for the apples and divided it by the number of pounds they came with. In doing that, I found that the Granny Smith apples were 75 cents per pound, the Golden Delicious were 66 cents per pound, and the Red Delicious, well, they were also going to be 75 cents per pound. So which one is the better deal? Technically, the Golden Delicious are going to be the better deal because they have the cheapest cost per pound. Going down to part C, it asks, how do I know, and explain your answer. And I would say my explanation for that is that it has the lowest per apple cost. Actually, it should be lowest per pound cost. So let's fix that, because it wasn't per apple. So I'm going to take and erase that, and we're going to rewrite that as pound. And did you notice a pound is abbreviated LB? That's some ancient British thing that we kept from when we left the British colonies years and years ago, like 2 centuries ago. All right, so anyhow, moving forward from here, we're going to take, and now, actually I want to talk about these apples for a second. If the Granny Smith had been the best price per pound, they might not have been the best choice still. The reason is Granny Smith apples are used for cooking. You don't really want to eat a Granny Smith. They just don't eat that well. The Golden Delicious, the Red Delicious, great eating apples. Granny Smith apples, those are the ones you cook with. Now we're going to go to the next question where we're looking at the crayons. And for that, I found that the 8-count box became 13 cents per crayon. The 12-count box became 20 cents per crayon. And the 24-count box, that became 16 cents per crayon. And in doing that, I ended up finding that the 8-box count was a better deal. 8-count box was a better deal. And once again, it was because it had the lowest price per crayon. Now you guys are going to take and jump over and do questions 3, 4, and 5. So 3 and 4 right there. 5's on the next page. Go ahead and pause your video and work on each of them. Number 3 is looking at peanut butter, and we're taking a look at the cost per ounce of the peanut butter. So we took the cost of peanut butter A and the cost of peanut butter B and divided each of them by the number of ounces. Now once again, I left some important information off on my answer key here. I should have taken both of those and said per. Actually, this is an ounce, not pound. So abbreviation for ounce is OZ. And then when I did that, I found that the better price per ounce is going to be peanut butter brand B. Now, something has to go in for taste here, guys, okay? So just because it's a better price per ounce does not mean it's going to be the better tasting peanut butter. Just because it's a more expensive peanut butter also does not mean it's going to be the better tasting peanut butter. So how do we know which one it is? Well, it's because brand B has the lowest price per ounce, so that's going to be your better deal. Scrolling down from there, our next thing we're looking at is fast drivers. So we have Albert, who's traveling 300 miles in 5 hours, and Benny is traveling 250 miles in 4 hours, and it wants to know who the faster driver is. Well, going from there, I would say Albert's 300 divided by 5 meant he was traveling 60 miles per hour, and Benny's 250 divided by 4 was going 62.5 miles per hour. So in answering the question, how do we know who's faster? Benny's per mile speed is 2.5 miles faster than Albert's. Now, something to point out, this time I picked the one that was a larger number because we wanted to know who was going faster. The person going faster is traveling the more distance in the same amount of time, in this case an hour. On the one above, we wanted to know the better deal. The better deal is a lower number per ounce. So you have to read the questions to make sure you're answering what they want you to answer. Next, we're going to jump over to number 5, and let's see if we can get that revealer to pop back up again. And come on, I'm not sure why it keeps disappearing on us. So tools and revealer, boop, there we go. So for this one, we're looking at 3 different cars, and we want to find out which one gets the best miles per gallon. So we had car A got 28.3 miles per gallon. Car B got 28.6 miles per gallon, and car C got 29.1 miles per gallon. And when I worked this, I almost selected car A as having being better because it was a smaller number, but it's not. Car C is actually the correct answer because they can go more distance on the same amount of gas, a gallon of gas. Car C gets the most miles per gallon. Scrolling down from there, we have more to answer. So on this one, it said, woo, that sure got messed up. Let's see if I can fix what happened there. We're going to see if we can delete one of those. There we go. It says, what are the methods that you used? And this is where we start working as a class again. What are the methods that you and your team members used to solve this types of problems? Well, what I wrote is I figured out which one of the units, that should be which right there, so let's change that word to which. One of the units I wanted to be, wow, bad mistakes here. I wanted to be my single unit in the unit rates. So for the last one it was gallons. For the one before that I think it was ounces maybe, or no, it was miles per hour, so it was hours. One before that it was ounces. I then divided that number from the other unit by the number in the unit that I wanted for my unit rate. And then from there, I compared the units. So there I answered the question on how I came up with the answer. And here we're going to take and start looking at some definitions. Remember, a rate is a ratio that compares 2 quantities measured in different units. Miles or distance, hours or time, different units. A unit rate is a rate where the denominator is 1, where the second unit has a value of 1. 1 hour, 1 gallon, 1 ounce, things of that nature. An example, an average person blinks 100 times in 4 minutes. How many times does that person blink in 1 minute? And a solution could be that they would blink 25 blinks per minute. Well, you divided the 100 and the 4 both by that 4 to find out how many would be in 1 unit. From here, you should take and pause the video and answer these questions, but we're going to go ahead and go over what I did. It says, you've explored and hypothesized rates through the unit rate exploration and definition of unit rate activities. During that work, you learned how to read, make sense of problems, and show a solution that makes the best decisions. With your team members, state your new understanding of unit rates. So what I did is that, oops, got a boo-boo in there again. Unit rates are rates where the value of the second unit is 1. Pretty straightforward answer there. Next, list in 2 sentences, list and describe the methods that were used in finding unit rates. First, I figured out which unit I wanted to be 1. Then I divided the numeric value of the other unit by the numeric value of the unit I wanted to be 1. And then finally, the last question here says, with your group, discuss, and write all the methods you and your team members have used to solve the unit rate problems. And please describe the detail and be as descriptive and detailed as possible. So what I wrote is I figured out once again which, yes, I literally copied this from up above, which one of the units I wanted to be my single unit in the unit rates. I then divided that number, or the number from the other unit, by the number that of the unit I wanted to be. Let's hold on, let me read with that. I then divided the number from the other unit by the number of the unit I wanted to be the unit rate. Yeah, now we're good. I then compared the units rates. So that answers that part. Now, the last thing we have to do is create a Frere model. In the Frere model, you guys go ahead and pause it. If you remember, the Frere model looks like this. Pause the video and go over what you have discovered and learned about unit rates. Here's the answers I came up with. A definition in my own word is that a unit rate is a ratio that is also a rate and where the second value is 1 unit. Facts and characteristics: it must be a ratio that is also a rate. Being a rate means that the units represent different concepts like miles and hours, and the second unit has to be 1. Examples: I gave 45 miles in 1 hour, or 3 strikes in 1 out. A non-example: 90 miles in 2 hours, not 1 unit, or 2 cats to 1 dog, not a rate, because remember we talked about earlier, cats and dogs are both animals, they're also both pets. Your homework, you're going to take and answer these 6 problems that are on here. Let's see if we can get it to go down. Boop, there we go. So we got 6 problems for you to work on your homework tonight. Make sure you give me good supporting work, just like the supporting work that I gave you in the example problems, so that I can give you good credit. I look forward to answering any questions you have in class tomorrow.